Tech Nuggets, VM Intro, and VMware Workstation. We're going to talk a little about basic reasons that virtual machines exist and what they do and why you might want these. So this is kind of a basic introduction to these concepts. And at the end, we're going to talk a little about VMware Workstation, which is what you can install on a regular, desktop PC so that you can create a home environment and some of the ins and outs of making that work. So let's start with some of the basic reasons you might want to virtualize. Like, what's that mean? Your normal computer that sits on your desk or your phone or anything like that spends 99% of its time doing one thing, which is nothing. It's so ubiquitous nothing that the CPU actually has a command called no-op, which is no operation, meaning do nothing. Most of a computer's life is spent waiting. We're waiting for the keyboard. We're waiting for the video. We're waiting for the drive. We're waiting for the RAM. We're waiting. And so while we wait, no-op is what happens. Oftentimes, the thing the computer waits for the most is the user, because we don't think nearly as fast as the computer does, which means we got a lot of excess processing power doing nothing. When we virtualize, we sort of bring all that together. We can aggregate all the little 1% machines together, and we can compress them into one physical machine. And we use this fancy piece of software called a hypervisor to sort of dole it out that chops up all our resources and lets us utilize multiple virtual machines inside one physical machine. And there's a term for that. It's called P to V ratio, physical to virtual ratio. So, in the 90s, we might have had a room full of 100, 200 machines. Now we can compress that down to 2 or 3 really big machines, but that means our power, our cooling, our physical maintenance issues become aggregated in sort of overall context to 1 or 2 big machines that we can worry about, rather than trying to worry about a data center full of all these machines and their heat. And the fact is, they're not doing that much most of the time. So there's a vernacular that goes with this topic, and it's very important because we can get lost in the the marketing lingo and all the different terms that Microsoft and VMware and all these other companies use to talk about their products. And oftentimes, wading through the terminology is the hardest part to understanding this. If somebody would just explain it in English, it'd be okay. Well, that's kind of what Tech Nuggets are here to do. So the big terms here in VMs are guests. That's the actual VM. A guest is a VM that, runs a process. It can be a whole operating system, or it can be as small as like a container and it does one little thing, and that's what it does. But oftentimes we can have Windows guests and Red Hat guests and Ubuntu guests, and those are guests. A host is an actual physical thing you can touch. It's a physical PC that runs an operating system called a hypervisor. And the hypervisor, here defined at the bottom, is the operating system we run that creates all these VM, options so that we can do that. And it's like a traffic cop. It hands out resources on a smaller scale. So if our host has lots and lots of physical RAM, our hypervisor might only give a small piece of that RAM to each guest as we go. And it manages all the access to the resources and that kind of stuff. It often has a web interface, is what we use now, to get at the hypervisor to manage the hosts and the guests. Oftentimes a hypervisor has that in it. Most often, real big hypervisors that you would run in a data center don't have any local, like if you go to the local console for it, it's just enough to put some IP addresses in it, and then you're expected to go to the web interface to do everything else. This is kind of a courtesy of VMware, their image about what, hardware-wise and a little bit of software-wise looks like. So our application, the orange box, might be Word. And Word runs in an operating system like Windows, and we sit in a hardware like your laptop. And so on the left side, we can see what that might look like. We've got CPU and memory and NIC and disk and all that kind of stuff. With virtualization, we slide another shim in there. VMware's term for their hypervisor is ESX, or ESXi is the term for there. So we can see we slide that shim in there. There are several other hypervisors, KVM, VirtualBox, several other ones that live in there, and they would be very similar in that ESX server box. They would do something very similar. But you can see inside it, we've got 2 different applications, 2 different operating systems, and a subset of the hardware that's offered in there. So it's creating those little divisions for each VM. So instead of getting all the hardware, the operating system gets whatever the hypervisor, presents to it. All right. There's two types of hypervisors in play here. And one is a type 1 hypervisor. And our graphic here is courtesy of Wikipedia, I believe. And it is basically a hypervisor you install. It even says bare metal. So I take the PC, I install the hypervisor on it, and that is the only thing it does. All of its resources are dedicated to its guests, which are little clouds at the top that say OS, which means nothing gets in the way of the hypervisor getting to the hardware. And its whole job is to go off and do that. A type 2 hypervisor is a little different of an animal. It's what would happen when you run Windows and then install VirtualBox or VMware Workstation. That's a type 2 hypervisor because there's another OS keeping the hypervisor from getting direct access to the hardware. So your hypervisor has to contend with things like, hey, I'm going to go play this great big video game that's going to suck up a bunch of resources. And the hypervisor and the video game have to duke it out with the operating system for resources. And oftentimes the hypervisor is going to lose, which means all of its guest OSs are going to lose. It makes it less efficient when we go to use it that way. So in the data center world, we're using type 1s. In the I want to run it on my laptop, we tend to be using type 2s. Type 2s are great for testing. They're great for home labbing. They're great for proof of concept. They're not generally what we're going to use in production just because you don't get the uptime out of the hardware, nor do you really get the resources and everything you want out of them. All right, so there's some other reasons we might want to virtualize. Snapshots and cloning are something that we'll get into a little farther in, but I'm going to talk about it a little here because it's a big deal in the VMware world. Snapshots basically let you take a saved game of a VM. So the best example is usually Windows updates, which take a long time, and when they go bad, the whole VM, the whole machine is wrecked, and you have to rebuild it from scratch. With a snapshot, I could take a snapshot before I do the updates, and if it goes south on me, I can pull some log files, I can see the error screens, then I can roll back to the snapshot and have a running machine and try it again, or try it differently. Or more importantly, if that VM is, say, $10,000 an hour, I can roll back to a working state and try to figure out what's going on while the boss doesn't lose their mind at $10,000 an hour when I say, yeah, it's down. And if it were a real machine and I say, geez, we did updates because we have to, and it died, sorry, boss, it's going to be 3 days while I get it fixed. We're losing $10,000 an hour. The boss will lose their mind at that point, and we'll be out of a job. So snapshots become very important at that point. Cloning fits in the same way. I can copy a VM. It's just software. They're just files. So I can clone it, and then I can, run the update ahead of time and see if it kills my clone. And if it kills my clone, maybe I can work out a process that makes it work. Then I go to the production machine and fix it. Take my snapshot, make sure, try out my, updates and hope they work. And if they don't, roll back to the snapshot, go back to the clone, play with it some more. It gives us some options to work with it. Cloning also comes in many of our classes where we work on what's called a gold machine. And we get the one machine right the way the faculty wants it. It's got all the right tools and all the logins and credentials and everything. And we turn it off and then we clone it 35 times and we give a copy to each student. And they're identical. I don't have to run updates on it. I don't have to do anything to it. It gets cloned exactly the way it is. So we have a lot quicker time to provision. We make what are called template machines. They're gold machines. And you make copies of them. If you've ever installed Windows Server, it can be a long time while you install Windows Server and then run all the updates to get it up to date. And then you're ready to start. And, it can take a day, 2 days to get all the patches installed and all the config you want done. And if you spent that time once and then you just cloned that machine for every time, the boss will show up and say, yeah, I need 4 Windows servers, I need a database server, I need a web server, I need this server, I need an application server. And you say, sure, bang, bang, bang. And you whack out a couple of quick clones and it clones it. And there you go. 10 minutes later, the boss is thrilled. You're thrilled. You didn't have to sit and build 4 Windows machines from scratch. You won't lose your mind. It's always a good thing. The last thing we get into is uptime. When VMs are clustered, and we'll talk a little about this in vCenter, some of the advanced vCenter features, the VM doesn't have to live on a specific host, especially when we use a SAN, which means the VM can actually move as it's running from one host to another. So if I have a piece of hardware that's going south on me, right? It's got a RAM stick that's bad or a disk that's bad. I can move all the VMs off of it while they're running, put it in maintenance mode, shut it down, do maintenance on it, bring it back up into the cluster, and then turn it back on and let VMs sort of migrate back onto it. That's what vMotion is we move running VMs on and off. Now you have to have multiple hypervisors working, and you have to have shared storage of a SAN to make that work. But this is what big data centers are doing to leverage it. At that point, a host just becomes a blob of CPU and RAM. And, you know, I'm not worried about the hard disk on it because the VM's hard disk lives on the SAN, and we can do some really cool data center-y kind of stuff with it. Let's take a quick discussion about the hypervisor. It gets a lot of love, right? There's a lot of awe inspired about the magical hypervisor. Truth is, it's not that magical. It's a 50 meg piece of software. Most of our hypervisors, type 1 hypervisors, are super cut down Linux kernels with some proprietary services and drivers on top. For example, ESXi is a Red Hat server sliced way down. They slice everything off it, and they build a very proprietary 50, 60 meg app that runs on top of it, and that way more of the resources are available for VMs. They don't want the local console to do anything. We don't want a big fancy GUI. We don't want all that stuff on the local console. That's why most of the admin is done in a web server, because all that happens on the client machine at that point. It's not happening on the server. They're just presenting resources, and there's no GUI locally on it. That's pretty normal for hypervisors of the type 1 variety. Type 2, yeah, you get a GUI. We're actually going to do some demoing with VMware Workstation to set up a home lab environment, and that's absolutely a GUI as it's going to run in Windows, as I'll show you here in just a second. So let's talk a little about VMware Workstation. It's a desktop hypervisor, so it's a type 2 hypervisor. It's going to let us set up a lab environment. So we're going to run hypervisors inside hypervisors. It's called recursive hypervisors. Believe me, there's a big performance hit that goes with this. So you want to know that up front. It's a lab environment. It's not a production environment, which means they're going to be slow. It's going to work, which is going to give you a chance to play with it, but it is definitely going to be slow. There are things you can do at a home level to make it work faster. Give it more RAM. VMs use lots of RAM. That's just the way they are. But RAM's pretty cheap, all things considered. So a lot of VMware hosts have buttloads of RAM on them. You can buy hosts in the desktop context, or I'm sorry, in the data center context that have terabytes of RAM because VMs use a lot of RAM. In a home environment, if you had 32 gigs of RAM on your machine, that would be a lot. And you could turn around and dole it out to multiple recursive ESXis and that kind of thing. The other thing that is very helpful, especially in a home environment, is fast disks. So if you're running an old platter drive, it can be kind of slow. If you can upgrade to an SSD or an NVMe drive, those are the newer solid state drives that don't have spinning disks in them, your performance will be much better. It will work quite a bit better. The goal here is to turn VMware Workstation into a home lab environment, kind of in a jam jar or a bottle where you can get at all the little pieces of it inside VMware Workstation. We can snapshot and clone different parts and pieces of it and look at them and that kind of thing. Our fundamental underpinnings that go with this are going to be what VMware Workstation will provide. It's providing all of the networking. So in order to keep it slammed inside a jam jar or a bottle, we're going to use the NAT settings, and I'll go into this in the demo, of VMware Workstation. So it's going to provide a gateway, a DHCP server, DNS, gateways, things like that. It's going to provide that networking underpinning so we don't have to set it up. And we'll see a lot of that in the demo, and I'll go over what some of that means so that way you can get a feel for how do I set some of this up. I'll probably do another video on how to install ESXi inside that environment, so that'll be another video after this one. So on to the practical demo. So this is VMware Workstation 15.5 Pro. It's the current release version of it. And you can see here, we're looking at kind of some basic options. I got some tabs for home, which is what we're looking at here. And I've got a Windows 10 VM that I built that's just a local VM. You can create a new VM and it'll create more tabs across the top. You can open an existing virtual machine if you had the files on your hard drive somewhere and you need to pull them in here, you do that. Or you can connect to a remote server, which would be ESXi or VMware vCenter kind of stuff. And the real discussion I want to have here is actually not super VM oriented, but it's the environment that the VMs that are created in this type 2 hypervisor live in. So I went to Edit and Virtual Network Editor, because when you install this, it's going to play some head games with your one physical NIC to create these other network environments that it's going to provide services to. And so there's really 3 of them, and I'm going to show it in my Windows 10 VM where you can edit a little bit, where you can see it says bridged, host only, and NAT. And bridge means any VM that's created that's set to the VMnet0 network will basically get services just like your host machine does. So if you're running, Windows and you get, DHCP from your local router or NAT device that goes to your cable modem, so will the VM that you create. It is bridged. It will get the exact same services, and it will look, from a network context, like another machine on that same network as a peer with your host machine. That's what bridged will do. Host only will allow your machine to communicate with the VM on this network. And you can see there's a subnet address. So there's a bogus NIC that gets created that your host machine can use, and I'll have an IP address on. And you can see down here there's DHCP settings. And you'll be the only thing that can talk to it because you'll be on the network with it. But it won't have outside world connectivity. So it won't be able to get updates or do DNS or anything like that. It'll basically be slammed into a very quiet network that has no connection to the outside world. There's this last option that is the most important one for our discussion, and that's NAT. And that's where the hypervisor, so VMware Workstation, is going to create a NATed environment. So it's going to provide DHCP services as well as NAT services and some very limited DNS services. And this becomes very interesting because at this point, we can create our home lab environment in the VMware Net 8, the NAT environment, and it will get connectivity to the outside world to run updates. VMs that are recursed, VMs on our internal network will eventually be able to bounce their way all the way out. There needs to be some discussion about how those settings work. So when we look at our NAT settings, we need to understand what we're looking at. What's our gateway IP? Because some of these things we're going to want to give a static IP address inside our environment. What does that mean? So we can see our gateway IP here. We can also see our DNS servers settings here. So if we have other ones we want to give it, we can do that. Or if we don't and we don't care, this IP address will become your DNS proxy. You won't be able to put any records in it, but you can certainly do some level of, out to the rest of the world. You'll be able to get out and do regular DNS type things that your local host machine would be able to do. Keep in mind that these 2 addresses, the 192.168.150.0 and 220.0, are not static. I've talked to a number of people that have Workstation installed. It appears that VMware sort of randomly picks that 3rd octet here so that the 2 of them are different than whatever your host machine is. And that way you'll be able to tell them apart when you see the IP addresses. And down here at the bottom, you'll be able to see a variety of different things for DHCP. So we'll pull that up, and you can see here it's given our subnet IP, right? And we're seeing our subnet mask, but we're also seeing where do DHCP addresses come from. It's the lower half of the range, so from 128 to 254. What that means is from like 3, because 2 is our gateway on our DNS server, so from 3 to 127 are static IP address range. So if I need to put a VM in there that has a static IP, but I don't want to stomp on my DHCP range, I'll put it in there in that range, somewhere outside of the starting and ending zone. So from 3 to whatever. This is a good time to start an Excel spreadsheet and start writing down, here's my DHCP ranges and here's my statics, and you can keep some documentation as to what's going on. Default lease times are kind of short. That makes sense in the VMware world. Normally they'd be kind of short. We don't really need them to be super long. That's kind of whatever you need it to be. It's a dogs playing poker kind of thing. What do you need it to be for your application? That sets up our basic environment for working with that. Let me pull up a VM so I can show you where those settings are. You can see I've got a Windows 10 here, and it's got a bunch of RAM and VMs and disk space, but you can see network controller is set to NAT here. And when I go into edit, you'll be able to pull it up and you can see I can select bridged, I can select NAT, I can select host only. I can actually go in and select the individual ones. So if I go into the virtual network editor and create additional ones because I want to run different, I can go in here and pick different ones. But oftentimes all you really need to do is pick NAT, and there's only one NAT in the default setting to set it up. And that'll bring it up. It'll put it in the network. I can hit play here and it'll boot my VM, and we'll be able to see it come up. Give it a little stretch back to its good size as it comes up. And I think I set mine to auto log in, which is, something in a home lab you can get away with, but you don't want to do that in the real world. And it'll log in, get an IP address, right? It's my Windows 10 box is doing DHCP, which is being provided by the Workstation. VMware Workstation is providing all that stuff and natting all that stuff. So we'll get in. We'll do a little time compression here because this can take a little while to come up. All right, so we finished booting. It took a minute or two, but you can see here in the background, I'm getting all my IP settings. So I've got 220.131, which is absolutely inside that range from 128 to 254. You can see I've got the right subnet mask, my gateway, that kind of thing. It doesn't show my oh no, it does show my DNS server at 220.2, which is what we expected. And when I go in and do things, and I want to surf the web, I can do, and we'll be able to see I'm getting name resolution. I can do NS lookups for google.com, and it'll tell me that, I'm using 220.2 as my name server, and it's not authoritative, but it shows me the IP addresses. So those are the settings we're using. Once we're in this, any VM that we create that lives in that NAT network will all live on the same LAN, which is going to be really important if you want to create a home lab where you've got ESXi and vCenter and other things all communicating, and they need to be in a network space that what the IP addresses are. You can slam it all into the same local LAN segment because it'll all be in 192.168. For me, it's 220.0/24, and they'll be able to communicate. There'll be some DHCP space, there's some static space, and you'll be able to configure things that need statics to have that kind of stuff. I did a vCenter video, so go check that one out. It'll go through more of the how do I set up vCenter and that kind of stuff. We're going to do an ESXi one, so go check that one out. It'll go through the basics of how to put ESXi into VMware Workstation so that you can look at it and work with it and that kind of thing. We can also talk a little about snapshotting. So I talked about it earlier. The little wrench here shows me my snapshot manager. And earlier, I made a clean machine, which is what I call my machines that are running and I know they work. And it says you are here, which means I've started that clean machine. You can have a chain of snapshots. You can fork them and have different chains. VMware is very clear. Snapshots are not backup. And the primary reason for that is a snapshot is what's called a diff file. So it keeps the original version, and then everything you do since the snapshot, it keeps in a different file, and it keeps track of what the differences are. So when you delete a snapshot, you merge the diff file with its main thing, its main hard disk file. It has to figure out what the differences are and re-merge all that. If you get too many snapshots over too much time, the diff files get too big, it won't reintegrate them all, and the whole thing will go to hell, and that'll be the end of it. So snapshots are not backup. They're great for doing what you're doing, but generally speaking, I don't run more than a month. And if it's a really busy machine, you probably aren't running any snapshots at all. Backup is backup. Snapshots are great for I need to do something and I'm not sure this isn't going to blow up on me in the next hour. They are not meant for backup, so keep that in mind. I can clone snapshots and do stuff like that. If I go up here and look at it, we can see under Manage, I can clone, I can clean up disks, but this is where I would clone a virtual machine. Normally when it's off, you clone it. You don't usually do it that way. But you can see all the different things in here. I can shut it down. Shutdown is the nice way of saying, hey, operating system, please power down normally. That's what you can see. It's like I went to shutdown and said, please power down. But if I were to go to power and say power off, I'm jerking the power out of the wall and it's off. So if the machine freezes and chokes and dies and isn't responding to the nice command, sometimes you have to go to power off and say, okay, you're done, and shut it off. So sometimes we get to that. Sometimes it's nice to get to power on to firmware, which is go into BIOS, set the BIOS settings, and I want to set it a certain way. I want UEFI or I want BIOS. This is power on to firmware, and we can do that kind of stuff. Under home, we can create new virtual machines. Typical is usually what I use. If I've got an ISO that I've downloaded from somewhere, I can select the ISO. If I've got it in an actual physical drive, you can see here I was installing Ubuntu 18.04 and I've got it set up already, so it knows it's there. Oftentimes I like to tell it later because it makes some decisions. If you give it the ISO, it'll make some assumptions that I don't always like. So sometimes I'll use the I will install operating system later, which will give me all the choices. You can see here I get Linux, I get Ubuntu, I can scroll down to the specific flavor of Ubuntu, 64 or 32. If I pick Windows, I'll get lots of different flavors of Windows. It goes all the way back to Windows 3.1. People run a lot of old stuff, and sometimes you need that specific version of whatever it was. You can even see there's ESXi, and we're going to do this in another video where we run ESXi inside it. So for our thing, we're going to pick Ubuntu, and we're going to pick Ubuntu 64-bit, which is the version of CPU that we have, and we're just going to call it U64, and it's telling me where it's going to put my machine. I happen to have a folder that I put things in, which I will call U64, and I put it on a different drive, right? I've got SSDs, that's going to make it run faster. My D drive is an SSD, so I run my VMs on a separate drive that's faster to make it work better. We can tell it how big a hard disk to present to the guest. So in this case, it defaults to 20 gigs. If you knew you were going to run a database server or a big file server, you might want to give it more. You can split the disks into multiple files. I often do store as a single disk because if I have to copy the files around, it's a little easier that way. Dogs playing poker, you do what you like. You can customize the hardware. You can kind of see a summary here, but if you wanted to customize your hardware, you can come in. This is the defaults that it starts with. 2 gigs of RAM, 1 CPU. If you say, well, geez, I really want it to run faster, well, you might give it 2 cores. It's one processor with 2 cores. You might give it a bit more RAM. Let's slide the slider up a little bit. Give it some more RAM. This is the part where you get to pick what network it's on. So you can pick bridge, you can pick NAT. This is also where we're going to go select our ISO. So I want it to boot to, my ISO. So, oops, typing the wrong thing in. There we go. We're going to pick, the ISO that we want, and we're going to pick desktop, and it's going to boot to that when it comes up. So that's what we want it to do, and that'll set all of our hardware settings. All right, so at this point you're looking, right, it built another tab. We've got Windows 10 and Ubuntu 64, and we hit the power on button, and it should power on, and it'll boot to the ISO, which is what we expect to have happen. And it likes to jerk around with the video size, and you can see it'll do it a couple of times. And I usually just tell it I finished installing, and it'll make a little message go away, and we'll probably fight with it a couple more times as it decides it's going to resize the video settings for something. So it's booting, booting, booting. Ubuntu does this. All the operating systems do this, right? As it heaves itself into the air, it's fairly normal. Probably do a little time compression here. All right, there we go. It was about 45 seconds as we gets us to our main, install screen. I want to install Ubuntu, so we say install, and we'll kind of walk through all the different options for installing Ubuntu here. All right, we're going to pick regular English. We're going to do a minimal installation, which is going to mean it's not going to install Office and all that other garbage. It's just going to install Ubuntu and I think Firefox, a browser, and we're done. If you were using it on a laptop or something where you had multiple graphics or Wi-Fi, you might need that, but we should be okay. It shouldn't need any of that stuff. We're going to tell it to erase and install Ubuntu. There are some other options you can do if you want to play around with your partition sizes or if you had other OSs or something, but since it's a blank VM, we don't have any of that. And it will ask to make sure that this is what we want to do. Time zone, it's always good to know what time zone we're in. Should be installing in the background. We're going to pick a name. And we're going to call it, ITS class 01. We pick a username. I like to have it automatically log in. It's a test VM. It's okay to log in automatically. It gets me to the desktop and gets it running. I enjoy that. Actual workstation at work, no, it's not secure to do that, but I could do that here. At the parts that are boring, I'll probably do a little time compression. We can see here at the bottom, just came up and slid off the screen, so I'll move things up a little bit. VMware Workstation is complaining and saying, oh wait, there's all these great tools you can install that'll make things better. And I'll say, never remind me, and it'll go away, which is kind of what we want right now, but we will talk. Tools are software that you install on your guest to make it realize, hey, you're a guest, play nice. Don't screw around and try to take over and all that kind of stuff. Just play nice, realize you're a VM, and it'll make it play nice. And Windows, the Workstation people have some very nice tools they install that come with VMware Workstation. In Ubuntu, we install Open VM tools, which are open source tools that do a really nice job at all that. I will do a little time compression here so we don't have to watch it do its thing. All right, so we get to the end, and it's going to want to restart everything, which is pretty normal. It's going to want to spit out the ISO. We may need to go tell it, hey, spit out the ISO, it's okay. Should leave us here at a remove the immediate installation. Now, one of the things that happens right here, you'll notice my mouse disappeared, and it can be really frustrating. And you'll notice in the lower corner, it says to return to your computer, press Control and Alt. You press them both at the same time, and it gives you your mouse back. So we're going to go up here, and we're going to right-click and go to Settings. And we're going to go down here, and we're just going to say use physical drive, and we're going to say connected. This is going to disconnect the ISO, so it doesn't try to boot to it. And we're going to click again. It's going to seize the mouse. That's the term we use is seize. We're going to hit enter. It's going to reboot. But now the ISO won't be in the virtual drive, and so it should boot off its local hard drive, which is what we want it to do. And I'm going to not fight with it this time. I'm going to resist the urge. And we're just going to let it boot. Normally. And again, I'll probably do a little time compression here because it's kind of boring to watch it boot. All right, there you go. You can see that we came up here. And it leaves us at the new Ubuntu screen. Now, I'll make this send canonical in the information. And there we go. So the little thing down here is a lot like a Windows Start menu, if you're familiar with that. And I will install the VMware tools. So my user that we set up is in the sudoers file, so I should be able to do things like install by open VM tools desktop. This will install the tools for it. It's going to ask me my password. And it'll go through and grind away and pick up the tools. And it'll go, since I use the -Y option, it's going to go install all the tools without asking me, should I go to that? Of course it's going to reset the video drivers because that's what happens when we go do that kind of stuff. So let's reboot it here again, just to give it a chance to get all the video drivers, and we'll zip through that rather rapidly with a little time compression. All right, there we go, and we're back. And it should handle now the idea that I can do this, and it will reset the video. So when we install the tools, we get some cool things to go with it. We're not stuck at that same little dinky video settings kind of thing. It installs video drivers and network drivers and system drivers to make it play nicely as a VM. So the tools are often very, very, very useful. In many cases, very needful if you want multiple VMs to play nicely with each other and to work well together. I hope you've enjoyed this Tech Nugget. We have more Tech Nuggets on this topic. We'll cover ESXi in our home lab environment, and we'll cover vCenter in a production environment, and we'll probably do a little bit on vCenter in a home lab environment as well. So see you next time for the next Tech Nugget.